All right, today we're going to dive into the incredible, slow-motion story of how our planet's landscapes get made. We're talking mountains, plateaus, and plains, how they're born from these amazing forces, and how they're constantly being reshaped. It's a tale of massive power and never-ending change. So let's just start with a really simple question. Think about the ground you're on right now. Does it feel totally, completely still? Well, the amazing truth is, no. It's actually moving. The Earth's surface that we live on is in constant, super slow motion. It's happening right this second, as you're listening. It turns out that every single landform you see is the result of this constant cosmic tug-of-war. There are two huge, opposing forces that have been shaping our planet for billions of years. And this planetary battle has two main players. On one side, you have internal forces, deep inside the Earth, that are always pushing the surface up or causing it to sink down. And on the other side, you've got external forces, things like wind and water that are constantly wearing the land down through erosion, only to rebuild it somewhere else through deposition.
Okay, so how does this epic battle actually create, the most dramatic landforms out there? Let's talk about mountains. These giants of our world have some pretty incredible origin stories.
So what's the official definition? What makes a mountain a mountain? Well, generally, it's got to be a natural elevation that's more than 600 meters. That's about 2,000 feet higher than the area around it. Think steep slopes and a pretty small summit at the top.
And geologists have basically sorted these huge rocky peaks into three main categories based on, well, how they were born. You've got fold mountains, block mountains, and of course, the fiery volcanic mountains.
This is so cool. You can actually demonstrate how the world's greatest mountain ranges, like the Himalayas or the Alps, were formed right at your desk. When the Earth's tectonic plates smash into each other, the crust just buckles and folds upwards, exactly like that sheet of paper.
Now, block mountains? They're a whole different story. They happen when huge cracks in the Earth's crust cause massive blocks of rock to get shoved up or to drop down. The parts that get pushed up are called horsts, and the valleys that sink down in between, those are graben. A classic example is the Rhine Valley in Europe.
And our third type, volcanic mountains. These things are literally born from fire. They're built from the ground up, layer after painstaking layer, by explosive eruptions of ash and lava. Over thousands of years, this process creates that iconic cone shape you see in mountains like Kilimanjaro and Mount Fuji.
Okay, get ready for a mind-bending fact. We all know Mount Everest is the highest mountain above sea level, right? But the volcanic mountain Mauna Kea in Hawaii is actually taller. If you measure it from its base way down on the ocean floor, it's over 10,000 meters high.
Okay, so let's do a quick recap. You've got fold mountains, which are all about buckling and crunching. Then you have block mountains, which come from the crust cracking and shifting up and down. And finally, volcanic mountains, built by eruption after eruption. It's just wild to think that places like the Himalayas and the Rhine Valley are both mountainous, but they were formed in such completely different ways.
All right, so we've talked about the jagged peaks. Now let's shift gears and look at a totally different kind of high-altitude landform. These huge elevated flatlands we call plateaus, or sometimes tablelands. So what exactly is a plateau? The key thing to remember is this unique combo. It's high up, way above the land around it, but it's got a big flat top. Seriously, just imagine a mountain with its peak sliced right off.
And these tablelands? We are absolute treasure troves for us. A lot of them, like the Chotanagpur Plateau in India, are just loaded with minerals. We're talking iron, coal, you name it. When rivers spill over their steep sides, they create massive waterfalls, which are perfect for generating hydroelectric power. And the highest one in the world, the Tibet Plateau, is so high it's nicknamed the roof of the world.
Okay, on to our third major landform. And for this one, you have to remember those external forces we talked about, the ones that wear down mountains. Well, that whole process of destruction is also an incredible act of creation. It's what forges the huge flat plains that became the cradles of human civilization. And the way it works is pretty straightforward, but you have to imagine it happening over millions and millions of years. Rivers basically act like nature's giant conveyor belts. They grind away rock and soil from mountains, carry all that stuff downstream, and then, as the river slows down, it drops its load of sand and fertile silt, building up these enormous plains, layer by tiny layer. So in total contrast to those towering mountains and high plateaus, plains are all about being low and flat.
I mean, these are huge, wide-open landscapes that are just perfect for things like farming and building communities.
Okay, so we've talked about all of this geology, but why does any of it actually matter to us? Well, it's because these landforms completely shape our lives. The story of how mountains, plateaus, and plains are formed is really the story of humanity itself.
And you can see a huge difference in how we live on these different landscapes. Life in the mountains, it can be really tough. You've got steep slopes, harsh weather, not a lot of land for farming, so they tend to be thinly populated. But life on the plains is just easier. You have flat land for growing crops and building cities, and it's easy to create transport networks.
But here's the thing. Even though they're challenging to live in, mountains are absolutely vital to us. They're like giant water towers for the planet. Their glaciers feed the rivers that billions of people rely on for drinking water and irrigation. They're also home to incredible forests and wildlife, not to mention a huge hub for tourism and sports.
And this is why the Great River Plains, like the Indo-Gangetic Plains in Asia, are where you find the most people on Earth. They just provide the perfect setup for civilization. You've got fertile soil for farming, flat land for building, and plenty of water. It's the whole package.
You know, all of this really brings us to a crucial point. These landforms aren't just cool geological features, they're precious resources that we all depend on. And that means we have a shared responsibility to take care of them.
So, I want to leave you with one final thought, a question really. As we build our world, as our cities get bigger and bigger, they're often built right on top of our most fertile plains. So the question is, what's the long-term cost of paving over the very land that feeds us? It's a real challenge we all have to think about.